calcium oxide, if it is react with the water, it forms a SLAKED lime. Suppose if it is react with the carbon dioxide, it forms what? Calcium carbonate. So for the 1 mark, they will ask what is lime water or milk of lime. 4% of the earth crust is mainly made up of what? Calcium carbonate, and it is naturally occurring. If you take the gypsum and if you add a water, it will become what? Plaster of Paris. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called S-block element. Under that, we have discussed about the general characteristics of compounds of alkaline earth metals, and we have discussed that what are the salts of oxoacids, and we have learned the anomalous behavior of beryllium, and also we have understood that the diagonal relationship between the beryllium with the aluminium. Today, let us move on to the next topic of this unit about the important compounds of calcium. In that, we are going to discuss about the quicklime, SLAKED lime, and also with the calcium hydroxide, that is a plaster of Paris. And we are going to understand more about the cement and their preparation and their occurrence, as well as their setting and their reaction we are going to learn. And lastly, we are going to understand the biological importance of magnesium and calcium. Okay. So let's see with the first important compounds of calcium, that is quicklime, and the formula will be goes like this, that is CaO, which is also known as what? Calcium oxide, which is also known as what? Calcium oxide. Let's see with that preparation. How do they prepare? Let's understand now. It is prepared by commercial scale by heating the limestone in a very high temperature around 1070 to 1270 Kelvin. You can see that the calcium carbonate, that is a limestone, which is upon heating, which gives to the calcium oxide with the liberation of carbon dioxide. Remember, this is a reversible reaction. Suppose if you do this entire reaction in a closed container, if calcium carbonate is undergo heating and forms a calcium oxide with the formation of carbon dioxide, again this carbon dioxide can react with the calcium carbonate. That is why during this reaction we have to expel the carbon dioxide to outside in order to avoid a reversible reaction. So it is a reversible reaction and it is an exothermic with the forward direction, and it ensures that limestone is comparatively converted into lime with the carbon dioxide which is allowed to escape from the kiln. This makes the carbon dioxide unavailable for the reverse reaction. Suppose if you do this reaction in a closed container, the carbon dioxide itself can react with the limestone, okay, and forms a different product. That is why during that process they will expel or they will allow the carbon dioxide to escape from the reaction and to obtain the calcium oxide, which is nothing but a quicklime. Let's see with the uses now. Physical property now. The physical properties of the quicklime will be goes like this. It is a white amorphous solid and it is highly stable, and even the fusion cannot be decomposed on it, and it has very high melting point around 2600 Celsius. Okay. Next is the chemical properties of quicklime. On adding the water, the quicklime forms a SLAKED lime. So if you take the calcium oxide and if you dissolve it in a water, it forms what? Calcium hydroxide, which is also known as what? SLAKED lime. Then water is added to the lime and it becomes a hot and cracks to form a white powder which is known as SLAKED lime. So the quicklime can absorb the carbon dioxide and also it can form calcium carbonate. So suppose if calcium oxide, if it is react with the carbon dioxide, it can also form what? Calcium carbonate. This is how the calcium oxide, if it is react with the water, it forms a SLAKED lime. Suppose if it is react with the carbon dioxide, it forms what? Calcium carbonate. Next is uses of SLAKED lime. Where we use this SLAKED lime? The lime is indispensable for the use for the mortar and for the plaster. It is also used in laboratory reagent for the gas adsorption, precipitation and dehydration, etc. And it finds an enormous use in the manufacturing of soap, in the rubber, varnish and the refractories and the lime bricks. Okay. To prepare the lime bricks also, we use a calcium oxide. It also found in the preparation of calcium carbide. So the calcium carbide can also be prepared by using calcium oxide with a basic calcium nitrate and a calcium bisulfite. It is an important primary material for the manufacturing of cement. So especially for the manufacturing of cement, we use a calcium oxide as one of the raw material, and it is used in manufacturing of sodium carbonate to form a caustic soda. So sodium, in the preparation of sodium carbonate also, we use this calcium oxide, and it is employed in purification of sugar and in manufacturing of dye stuff. So these are the main uses of calcium oxide, which is nothing but a quicklime. So in your examination, any one of the important compounds of the calcium will be given to you. So you must know the preparation with the physical property, chemical property along with 2 to 3 uses. Okay. Next is calcium hydroxide, which is also known as what? SLAKED lime, and the formula will be CaOH twice. Let's see with the preparation. Already we have understood that when you take the calcium oxide, if you dissolve it in a water or if you add the water, it forms what? SLAKED lime. Okay, that is CaOH twice. So SLAKED lime is a white amorphous solid, and the aqueous solution of SLAKED lime, which is known as what? Lime water, and the suspension of SLAKED lime in water, which is known as milk of lime. So for the 1 mark, they will ask what is lime water or milk of lime. If you take the suspension of SLAKED lime in water, we say it is milk of lime. If you say it is lime water, it should be consist of aqueous solution of what? SLAKED lime. Okay, these two differences you must know, and it is very important. Next is chemical properties of this calcium hydroxide, which is nothing but a SLAKED lime. So when this calcium hydroxide, when it is react with the carbon dioxide, it forms what? Calcium carbonate with the formation of water molecule. So when carbon dioxide is passed to the lime water, it turns milky due to the formation of calcium carbonate. So I think in your first PUC, when you do the salt analysis, you will understand that if the compound which consists of calcium, it gives a test known as calcium carbonate test. Suppose if your salt is calcium carbonate, you will understand this. If you pass the salt solution to the lime water, it turns the lime water to be milky, and that confirms that the presence of carbonate in your compound. So hope you know that. And by passing the excess of carbon dioxide, the precipitate will be dissolved to form a calcium hydrogen carbonate. Suppose if you take the calcium carbonate and again if you wanted to react with excess of carbon dioxide, it forms what? Calcium hydrogen carbonate. The milk of lime, when it is react with the chlorine to form a hypochlorite, a constraint of bleaching powder. You can see that the milk of lime, when it is react with the chlorine, it forms what? Calcium oxychloride, which is also known as what? Bleaching powder with the formation of calcium chloride with the formation of water. This is how it reacts with the carbon dioxide and forms what? Calcium carbonate. When it is react with the excess of carbon dioxide, it forms a calcium hydrogen carbonate. When it is react with the chlorine, it forms a bleaching powder. Next is uses of calcium hydroxide. It is used in preparation of mortars and building materials, and it is a whitewash due to the disinfectant nature, and for making the glasses as well as for tanning industry, it will be mainly used in the preparation of bleaching powder, and for the purification of sugar also we use a calcium hydroxide. Next is other important compounds of the calcium is calcium carbonate, which is also known as what? Limestone. So hope you know that what is limestone. Sometime you would have seen in your lifestyle that where we use a limestone as one of the paint material in our olden days. We used to dissolve in it in our water and we used to paint for our houses. Is it right? So that we are going to discuss now. The occurrence we will understand. The calcium carbonate occurs in nature. It is estimated around 4% of earth crust is made up of what? Calcium carbonate, and calcium carbonate cycle is composed of rock, mineral, water as well as the plant and the animal material, and it is formed naturally as a mineral and the rocks, and sometimes it includes as calcite limestone or the chalk or in the form of marble or with the organoite. Okay, the minerals and the rocks which imparts the calcium carbonate in the natural water sources result in a hard water. In fact, the calcium carbonate is a main source of or a main cause of water hardness, and it is also a major constant of the compounds of shells and the skeletons of animals. Suppose if you go to the sea or to any ocean, you would have seen that most of the marine animals, they have a shell. Okay. So the shell itself will be made up of what? Calcium carbonate, because it is a protecting covering layer to that particular animal. And also, you know, not only this calcium carbonate will be have a protecting shells for the animal, especially to causes a hardness in our water also, this calcium carbonate is a main mineral. And remember, 4% of the earth crust is mainly made up of what? Calcium carbonate, and it is naturally occurring. Let's see with their preparation now. The calcium carbonate is prepared by adding the water to the calcium oxide to get a calcium hydroxide. The calcium dioxide is passed to this solution and a precipitate of calcium oxide will be formed, and industrially it is called as precipitate calcium carbonate. What we call for this? Precipitate calcium carbonate. Here you can see that this is a quick lime, that is a calcium oxide. When it is react with the water, it forms a calcium hydroxide, which is a SLAKED lime. Is it right? When SLAKED lime, again when it is react with the carbon dioxide, it forms what? Calcium carbonate with the formation of water molecule. This is how, by using the quick lime as well as by using SLAKED lime, you know, we can prepare the calcium carbonate. Next is uses of calcium carbonate. So the calcium carbonate will be mainly used in construction of industry as a building material, as a limestone, marble, or in the form of chalk, and it is also used as an ingredient for the cement. So most of you, have you heard about how they will build a KRS dam? So in the earlier days, in the older days, they have constructed the KRS dam by using calcium carbonate, by using eggshell along with the water molecule. So on those days, calcium carbonate was very much abundant in the earth crust. It will become very hard on cooling. That is why they will use this as a cement on those days to construct the buildings. Okay. The calcium carbonate in the form of chalk will be used as filler in the paper industry, and it is very cheap to make a bright opaque paper. The limestone will be used in decoration and for the construction, and the main use is contribution to making of mortars, and it is used in bonding of bricks as well as with the concrete, blocks, stones and tiles. Limestone, which is also used in steel industry, ornamental stones and chemical and optical uses and mineral specimen, and limestone can also be used to make the glasses, and it is also used as antacid and mild abrasive in a toothpaste and the constituents of chewing gum, and in filter in cosmetics. Not only in the chewing gum, we use this calcium carbonate in making of cosmetics, in making of ornaments, and also in the steel industry, in the antacid preparation also they will use. Next is plaster of Paris. So we know that plaster of Paris, which is also another important compounds of calcium. Is that right? So how to name this plaster of Paris? Calcium sulfate with the half molecules of water per molecules of the salt, which is known as plaster of Paris, and that can be written as calcium sulfate dot half water. This is a formula for plaster of Paris, which is also known as what? Calcium sulfate half water molecule. So let's see with their preparation. The plaster of Paris is prepared by heating the gypsum at 120 degree in rotatory Kelvin, where it gets partially hydrated. So here I have taken out the gypsum, which is heated around 120 degrees Celsius. It forms what? Calcium sulfate with the water molecule with the liberation of water. So this indicates that the temperature should be kept below 120 degree, otherwise the rehydration will be taking place and the setting property of the plaster will be partially get reduced. So if you don't keep the temperature below the 120 degree, again rehydration will be taking place, which means to say that this oxygen again it will be absorbed by the calcium sulfate and itself it can form a gypsum. That is why while making this plaster of Paris, they will keep the temperature below 120 degree. Above the 120 degree, no water of crystallization is left and calcium sulfate is formed, and this is also known as dead burn plaster. If you increase the temperature around 120 degree, there will be no water at all. So if you remove the water from this compound, it will become what? Calcium sulfate itself with no water molecule. This is known as dead burn plaster. So we cannot use to make the any things by using that plaster. Okay. Next is properties of plaster of Paris. Plaster of Paris is a white powder. When it is mixed with the water, it evolves a heat and quickly set into hard porous mass within 5 to 15 minutes. During the setting, the slight expansion in the volume which occurs, which fills the mold completely and takes the sharp impression. The setting of plaster of Paris is believed due to the rehydration and reconversion into gypsum. Here you can see that this is a plaster of Paris. When it is dissolved in a water, it will form what? Gypsum. Again, if you heat the gypsum, you will get the plaster of Paris. You will get what? Plaster of Paris. Suppose if you do the hardening, again you will get the gypsum. This properties of plaster of Paris is mainly due to the rehydration or reconversion. When you take the plaster of Paris, when you do the hydration, it will forms a plaster of Paris. When you take the plaster of Paris, when you do the rehydration, it will form what? Gypsum. Okay. This is one of the speciality between the gypsum and plaster of Paris. In the first step, it is called as setting stage, and the second is a hardening stage, and the setting of plaster of Paris is catalyzed by a sodium chloride, and it reduces the borax or the alum formation. So the first step is the setting, second step is hardening. So already during that preparation I have explained that if you take the gypsum and if you add a water, it will become what? Plaster of Paris. That plaster of Paris itself, it will take 15 to 5 minutes to become very hard. Once it becomes very hard, we can make it into the different shape, or we can obtain a desirable shape as we want. Okay. During that setting processes, they will use the sodium chloride as a catalyst because it avoids the formation of alum with the borax formation. Next is uses of plaster of Paris. So all of you know about plaster of Paris, especially for the making of Ganapati and all, they'll use the plaster of Paris. Not only for making the Ganapati, especially for making the household items, they'll use the plaster of Paris. And also in order to make the binding to the broken hands to the legs also, nowadays still now also they'll use the plaster of Paris because it will give a supporting to the broken bones. That is why if the person which is having a broken hand with the broken legs, first they will suggest to take the plaster of Paris bandage. Why? Because it will causes the supporting to that bone or to the leg to helpful to form a correct bone formation or to the correct bone development. Okay. So in the surgery for setting the broken or with the fractured bone, plaster of Paris, and for making the cast for the statues and with the dysentery and with the surgical instrument also, and most of the times you would have observed that it is made up of plaster of Paris, and making the blackboard chalks and construction of industries, they'll use this plaster of Paris. Magnesium sulfate, heptahydrate, it is commonly known as Epsom salt, and it will be represented like this. Magnesium sulfate, heptahydrate, which is also known as what? Epsom salt. This is how we can easily remember the 4 important calcium salts, or with the 4 important compounds of calcium. One is quicklime, SLAKED, calcium carbonate, and plaster of Paris. So how do they prepare the cement? Let's understand now. Cement is an important building material which is also known as what? Portland cement. Which is also known as Portland cement. This is called because it resembles the natural limestone quarried in the Isle of Portland and England. So the first occurrence of Portland cement was come about in 19th century. In 1824, Joseph Aspdin Leeds Manson took the patent on the hydraulic cement that was coined as a Portland cement. He named the cement because of it is produced in a concrete that resembles the color of natural limestone in the quarried on the Isle of Portlands of England. And today the Portland cement is widely used to make the buildings as one of the raw material, and about 1.56 millions of the tons which is produced every year. This is a small story behind how they will call the cement as a Portland cement? Because it was first found in Portland of England, okay, and it was found out by Joseph Aspidi. Next, let's see with the composition of the cement now. Cement is a product which is obtained by combining material rich in lime, calcium oxide with the other material in such a way the clay which contains silicon dioxide along with the oxides of aluminium and iron and magnesium. You can see that what all the component will be present in cement. That is, calcium oxide will be found around 50 to 60%. Silicon dioxide will be present around 20 to 25%. Aluminium oxide will be found around 5 to 10%. Magnesium oxide will be around 3%. Iron oxide will be around 1 to 2%. And silicon trioxide will be around 1 to 2%. The good quality of cement and the ratio of silica and alumina should be between 2.5 to 4 in the ratio of limestone. Remember, you would have seen that if the construction is done with a low quality of cement, then the construction will begin failure. Is it right? That is why the people will go with the good quality of cement, and this good quality of cement must consist of 2.5% of what? Silica along with the alumina, that is aluminum oxide. The ratio of the lime and the total of the oxides of the silicon and aluminum and iron should be close as possible to 2. The raw material for the manufacturing of the cement are limestone and clay. The clay and limestone are strongly heated together to fuse and to react to form a cement clinkers. Okay, this is how, in order to get a good quality of cement also, they'll change the composition into 2.5 to 4. Next is setting of cement. Let's see how do they do the setting. The cement sets when it is mixed with water by complex series of chemical reaction. Still, only the partly which is understood, when it is mixed with water, the setting of the cement will be taking place and give rise to the hard mass. This is due to the hydration of molecules of the constituents and their rearrangement. The purpose of adding the gypsum only to slow down the process of setting of cement and it get sufficiently hardened. So during this process, when we take the composition of the cement, we also add a gypsum. Why is it? Because it allows the hardening of the cement. When we mix the water to the cement, we all know that it will get hydrated and it will increases its mass and we can use it for the construction. So why this hydration will be taking place? Only due to the water molecule which reacts with the cement, which consists of the different composition of the element, undergo rearrangement, and due to this, it increases its mass and also get hydrated very easily. Next is uses of the cement. So for building the floors and concrete and reinforced concrete, beams and columns and roofing and piles and bricks and mortar and panels, as well as for the plaster, we use the cement, and for the transport also, for the road and pathways, for making the roads also, we use the cement. For making the water pipes, water culverts, and for water drains also, we use the cement. And for civil ducts as well as with the retaining walls and silicos and warehousing poles and pylons are also made by using cement. Fencing, which is also done by cement. And in agriculture, especially for building, processing, housing and feed lots, and also for the irrigation especially, we use a cement. So these are the few important uses of the cement where it is used in everywhere, especially for the construction. Next is biological role of magnesium. So in the last class, we have understood that the biological role of the sodium and potassium in the group 1 element. Similarly, in the group 2 element, we have a 2 element, especially the magnesium as well as the calcium. Why it is important to the human life? Let's understand now. The magnesium is essential element for the biological system. Magnesium occurs typically as magnesium 2 plus ion, and this is an essential nutrient for our life and present in every cell organism. For example, the ATP, that is adenosine triphosphate, the main sources of energy in the cell must be bounded with the magnesium ion in order to be biologically active. So, during the formation of ATPs in mitochondria, in every cell will prepare the ATP that will be goes and occupies in a mitochondria. It will be in the form of magnesium ion. The magnesium play a very important role in stability of all polyphosphate compounds in the cell, including those which is associated with the DNA and RNA synthesis. During the preparation of DNA and RNA also, we need a magnesium ion. In plants, if I talk, the magnesium is an integral part of chlorophyll, and the chlorophylls are the green pigments which is found in a leaf of the plant, which are responsible for photosynthesis. So, especially for the plant as well as in animal, magnesium play a very important role. And in the typical adults, they require the magnesium ions around 200 to 300 milligram of the magnesium daily. Next, we will see with the biological role of calcium now. The calcium is an essential element in the living system which play a very important role in metabolism of nitrogen in plants. So, during the metabolism of nitrogen, we know that nitrogen will be available in the air. It cannot be directly utilized by the plants. So, some of the root bacteria, it will convert atmospheric nitrates into nitrites that will be utilized by the green plant. During that process, this calcium play a very important role. So, in some plants, when the deficiency of the calcium, which also lead into the poor absorption of nitrogen, the lack of calcium in the plant nutrition, which also causes a reduction in number and the size of chloroplast. If calcium deficiency is there in the green plant, chloroplast formation is also get reduced. So, if chloroplast production is reduced, automatically their process of photosynthesis which is also get reduced. That is why the farmers, they'll keep the calcium content very high in the plant by adding the calcium carbonate to the soil. So, the calcium is the most abundant inorganic cement in higher animals and located in principally in the bones, teeth, appetite, etc. The calcium phosphate is a mineral and blood is also a huge reservoir for the calcium in animals, and calcium distributed throughout all the tissues where it has a special role in controlling the nerves, impulses transmission, muscle action and blood clotting and the cell permeability. We all know that our body which is made up of bones. Bones are usually made up of calcium. That is why nowadays, due to the calcium deficiency, most of the people, they will go for the nutrient supplements they will take. Is it right? And also our teeth itself which is made up of the calcium. Not only it is present in the bones as well as in the teeth, it helpful in blood clotting as well as in the cell permeability and also in the nerves transmission or with the impulses transmission we can say. And calcium deficiency which is exhibited by onsets of rickets. So, in your lower classes you would have studied that the deficiency of the calcium which also causes the rickets in the children especially. Why is it like that? If the bone development is not good in a particular person, then the person which looks very different and that problem will be also known as rickets. Okay. The failure of blood clotting mechanism and nervous disorder and convolvulus muscle contraction and vitamin D are improves absorbability the calcium ion. The vitamin D treatment in the rickets is based on this effect. Larger intake of the calcium can also lead into the excess of calcification, which causes the kidney stone. Remember, if the person is having the deficiency of the calcium, if he take the excess of calcium in the form of vitamin D, what will happen? Again, the person may get the kidney stone. That is why this adult person must have 25 grams of magnesium and 1200 grams of calcium and 5 grams of iron and 0.0 grams of copper. So these many grams of calcium, magnesium and iron will be required for the adult person. So hope you understood with the biological importance of calcium and magnesium. So by this, I like to say that I have completed this unit. What are all the things which I covered in this session? That is the important compounds of calcium as well as with the biological role of magnesium and calcium. It is very important for the examination point of view. Have a look on it. Wherever you are not understanding the preparation, pause the video and write the reaction and please practice with the reaction. We'll meet you with the next unit. Till that, take care, be safe. Thank you.